For as long as humans have looked up at the stars, we have wondered what lies beyond. The night sky, with its quiet immensity and celestial brilliance, has never ceased to provoke questions that pierce the limits of our understanding. Are we alone? What awaits us out there? Could we ever leave Earth not merely to visit other worlds, but to call them home? This is no longer a question of myth or poetic musing. It is becoming one of science, engineering, and ultimately survival. The idea that humanity might one day live on other planets is no longer confined to the pages of science fiction. It pulses through scientific journals, aerospace laboratories, and the corridors of philosophy departments alike. It asks not only what is technically possible, but what it means to be human in a universe that might allow us to transplant our civilization among the stars. But let us begin not with rockets or domes on Mars, but with the fundamental impulse behind the question. Why would we want or need to live on other planets? On one level, the answer is pragmatic. Earth is vulnerable. It is a single point of failure for our species. Asteroid impacts, pandemics, supervolcanoes, nuclear war, climate change, all pose existential threats. Spreading humanity across multiple worlds could serve as a form of insurance, a way of hedging against annihilation. Yet there's more. There is the curiosity that drives a species that once walked out of Africa and into every corner of the Earth. The same restless energy that carried Polynesians across the Pacific and sent Apollo astronauts to the moon. There is a deep-seated drive not only to survive, but to explore, to expand the realm of the possible. Living on other planets is, in many ways, the next frontier in this ancient journey. Still, there is a gap between dreaming and doing. The stars are silent, the distance is vast. No human has ever gone further than the moon, and even that was half a century ago. The only planet we truly know how to live on is the one beneath our feet, a world that cradled our evolution with its breathable atmosphere, liquid water, magnetic field, and forgiving climate. Mars is often touted as the most likely candidate for the first human colony. Its day is roughly the same length as Earth's, and it has polar ice, seasons, and landscapes that, at a glance, are eerily familiar. But its reality is anything but hospitable. The atmosphere is over 95% carbon dioxide, with only trace amounts of oxygen. Surface temperatures can swing from a relatively mild 20 degrees Celsius during the day to minus 100 degrees Celsius at night. The radiation on the surface, due to the lack of a magnetic field, is intense enough to significantly increase cancer risks for unprotected humans. Living on Mars would require not only habitats capable of sustaining life, but solutions to problems we've barely begun to solve. We would need to grow food in sterile soil or hydroponic farms. We would need to recycle every drop of water, every breath of air. We would need to develop medical care systems isolated from Earth. And we would need psychological resilience for the crushing isolation, the 20-minute delay in communication, and the knowledge that help is millions of kilometers away. Then there is the issue of gravity. Mars has only 38% of Earth's gravity. We do not yet know how long-term exposure to such conditions affects the human body, though experience with microgravity on the International Space Station gives cause for concern. Muscle atrophy, bone loss, changes in vision, immune system weakening, these are just some of the effects astronauts have faced. How might children develop in such an environment? Would reproduction even be viable under such conditions? And yet, despite all these challenges, we are advancing. Private companies like SpaceX are pushing the boundaries of launch technology. SpaceX's Starship, for example, is designed with the explicit goal of enabling mass transport to Mars. NASA's Artemis program plans to return humans to the moon and establish a sustainable presence there as a precursor to deeper exploration. China, Russia, the European Space Agency all have set their sights on planetary exploration in the coming decades. This convergence of ambition raises a tantalizing question. How soon could it happen? Some claim it could be within our lifetime. Elon Musk has suggested we could see the first human landing on Mars in the 2030s, with the beginnings of a settlement shortly thereafter. Others are more cautious, pointing out the immense technical, biological, and economic hurdles that must be overcome. Colonizing another planet is not just about getting there. It's about staying alive, building infrastructure, reproducing, establishing culture and governance. In short, creating a second cradle for human civilization. And Mars is only the beginning. Some thinkers argue that settling the moon might come first. It's much closer, just a 3-day trip, and offers valuable experience for living off Earth. Though it lacks an atmosphere and has more extreme temperature swings than Mars, it could serve as a testing ground for life support systems, mining technologies, and in situ resource utilization. Beyond Mars and the Moon, other worlds beckon with a quieter voice. Europa, one of Jupiter's moons, is believed to have a vast subsurface ocean beneath its icy crust. Could life exist there? Could we one day live beneath the ice in domed habitats, drawing energy from tidal forces and subsurface chemistry? Titan, Saturn's largest moon, has lakes of liquid methane and a thick atmosphere. It is unimaginably cold, but its chemistry is fascinating, and it may hold the raw materials for life support systems of the future. All of these options, however, force us to confront a deeper issue: our biology. We are Earth creatures, bound to a narrow range of environmental parameters. To truly thrive elsewhere, we may have to change ourselves. Some scientists have suggested that genetic engineering could be used to help humans adapt to new planetary environments. Others envision cybernetic augmentation, or even uploading consciousness into machines that could withstand conditions lethal to flesh and bone. But this raises uncomfortable philosophical questions. If we modify ourselves too much, are we still human? Is a genetically engineered colonist with enhanced lungs and radiation resistance truly a representative of Homo sapiens, or something new? What does it mean to live on another planet if our minds are running in silicon bodies buried beneath a Martian lava tube? There is also the ethical dimension. Should we terraform Mars or Venus to make them more Earth-like? The idea is not new, it has been proposed for over a century. Some scientists believe we could warm Mars by releasing greenhouse gases or placing orbital mirrors to reflect sunlight onto its surface. Over centuries, it might develop a thicker atmosphere and warmer climate. But terraforming would be an act of planetary-scale engineering with consequences we cannot fully predict. And if microbial life already exists on Mars, do we have the right to alter its habitat? These are not idle speculations. They force us to confront the intersection of science and values. It is not enough to ask what we can do, we must ask what we should do. Colonizing another world is not just a technological challenge, it is a civilizational choice. Still, the lure of the stars remains strong. And perhaps this is not surprising. The same processes that gave rise to Earth exist throughout the cosmos. Planets form around other stars. Some lie in habitable zones where liquid water might exist. The Kepler and TESS missions have identified thousands of exoplanets. Some are Earth-like in size and orbit. Might one of them be suitable for human life or already host its own? But even the nearest potentially habitable exoplanets are light years away. Proxima Centauri b, for example, lies 4.2 light-years away. With current propulsion technology, it would take tens of thousands of years to reach it. Breakthroughs in propulsion, nuclear fusion, antimatter drives, solar sails accelerated by lasers could shorten the trip, but such technologies are still largely theoretical. And so we return to the question, when will people be able to live on other planets? The answer, as with so many things in science and philosophy, is complex and layered. It depends not just on technology, but on will, cooperation, ethics, biology, and luck. It may be within this century, or it may take centuries more. But the trajectory is clear. Humanity is on the cusp of becoming an interplanetary species, not because it is easy, but because it is necessary.